Hello everyone. Let me start with a fun question. Have you ever stood in front of a mirror and thought, wow, I look amazing today, only to realize later, oh wait, that's just good lighting? That's reflection in action. Whenever light falls on a surface, some of it bounces back. This bouncing back is what we call reflection. Formally, reflection is defined as the return of light into the same medium after striking a surface. But here's the twist, not all the light bounces back. If the surface is opaque, some gets absorbed. If it's transparent, a bit sneaks through and the rest is absorbed. So, reflection is that polite portion of light which says, "Excuse me, let me just go back the way I came." And the best part? Without reflection, you wouldn't even see me, your books, or even your favorite pizza. Because non-luminous objects rely on reflection to be visible. Now, let's talk surfaces. Imagine trying to admire yourself in a bucket of muddy water. Not very glamorous, right? That's because rough, unpolished surfaces scatter light all over the place. But if you look in a shiny metal spoon, suddenly you get a neat little image staring back at you. Smooth, polished, silvered surfaces reflect nearly all the light falling on them, giving us crisp images. That's why a plain mirror, highly polished and silvered, reflects almost the entire beam falling on it. Meanwhile, rough walls or old school blackboards, they reflect light in every direction, but no clear image forms. So next time you check your face in your phone's black screen, thank the smooth glass for reflecting back your sleepy morning look. Alright, let's zoom into the superstar of reflection, the plane mirror. Did you know a plane mirror is basically just a thin sheet of glass with some science magic at the back? Here's how it works. One side of the glass is polished to make it smooth. Behind that, a layer of silver or mercury is deposited. That's the real reflecting surface. And to keep that silver safe from scratches or tarnish, it's further coated with an opaque protective layer. So, when light enters from the polished front, it zips through the glass, hits the silvered back, and boing, bounces back into the room. In short, when you smile into a mirror, you're actually seeing light that went inside, hit the silver, and came running back out saying, "Here's your face, freshly delivered." Now, reflection isn't always the same. Just like people, surfaces have personalities too. Broadly, we've got two types. Number 1, regular reflection, neat, disciplined, like a marching parade. Number 2, irregular reflection, chaotic, like kids running out of school when the bell rings. The difference comes down to the surface. Smooth surfaces produce regular reflection, while rough surfaces scatter rays in irregular reflection. And here's the cool part, both still follow the same laws of reflection. It's just that the outcome looks very different depending on whether the surface is smooth like a mirror or rough like your notebook cover. Let's focus on regular reflection. Imagine a beam of light as a group of well-trained dancers. When they hit a smooth, polished floor, like a plane mirror, they bounce back in perfect coordination. In this case, the reflected rays remain parallel. The image is clear, sharp, and steady. That's why mirrors are image makers. The rule here is simple. The angle of incidence equals the angle of reflection. Or said out loud, the angle at which light comes in equals the angle at which it bounces out. But here's a catch. Since all the rays move in one fixed direction, you can only see the image from a particular spot. It's like a stage performance. Sit in the wrong seat and you'll miss the show. Now for the fun cousin, irregular reflection, also called diffuse reflection. This happens when light falls on rough or uneven surfaces like walls, paper, or your messy desk. Although each ray follows the law of reflection individually, the surface bumps and dents make them bounce off in random directions. That's why reflected light spreads everywhere. And you know what? This is a blessing. Because if light only reflected regularly, you'd only see things from a very specific angle. Imagine seeing your friend's face only if you stood in exactly one spot, awkward. Thanks to irregular reflection, light scatters and we can see objects from almost anywhere in the room. Everyday visibility, totally powered by diffuse reflection. Alright, time to flex some math muscles. Suppose a parallel beam of light falls on a plane mirror at an angle of incidence equal to 30 degrees. What happens? Step 1. Remember the law, angle of incidence equals angle of reflection. So here, reflected angle equals 30 degrees. Step 2. Check the nature of the rays. Since the surface is smooth, the reflected rays remain parallel. Step 3. Deviation. The beam is turned by twice the angle of incidence. So, deviation equals to times 30 degrees, which is 60 degrees. So the mirror says to the light beam, you came in at 30, I'm sending you back at 30, but overall I'm twisting your path by 60. That's why in problems, always think the mirror doubles the angular fun. So let's wrap this shiny story. Reflection is simply light bouncing back into the same medium. A plain mirror, with its polished glass and silver coating, reflects nearly all incoming light. There are two main flavors, regular reflection, which gives crisp images, and irregular reflection, which spreads light in all directions so that we can see objects around us. And remember, both follow the same golden law, angle of incidence equals angle of reflection. The big takeaway? Without irregular reflection, the world would look like a hall of mirrors, only visible at very specific spots. Thanks to diffuse scattering, your room, your books, your friends, and even your pizza are visible from any angle. I hope this clears up the magic of reflection. Till next time, keep your curiosity polished, just like a good mirror.